Let's talk about atomic theory! Yay! To start out, John Dalton's theory of the atom was the first. In 1808, Dalton's atomic theory explains the law of conservation of mass through the concept that chemical reactions involve merely the combination, separation, or rearrangement of atoms, and that during reactions atoms are not subdivided, created, or destroyed. By relating atoms to the measure property of mass, Dalton turned this guy's idea into a scientific theory that could be tested by experiments. Although John Dalton thought atoms were indivisible, investigators in the late 80s proved otherwise. Investigators observed that when current was passed through the tube, the rays were deflected away from a negatively charged object during the cathode ray experiments. In 1897, J.J. Thomson found that a ratio of the charge of cathode ray particles to their mass was always the same, concluding that all cathode rays must be composed of identical negatively charged particles, which were named electrons. Along with the use of cathode rays, in 1886, Goldstein discovered a ray going the opposite direction when conducting the cathode ray experiments, which meant there was a positive charge. In other words, protons. With J.J. Thomson's discovery of the electron and Goldstein's discovery of protons comes forth the plum pudding model. So the plum pudding is a dessert, and the cake is supposed to represent the positive charge, and the random bits of fruits represented electrons. More detail of the atom structure was provided in 1911 by New Zealander Ernest Rutherford and his associates Hans Geiger and Ernest Marsden. The scientists bombarded a thin piece of gold foil with fast-moving alpha particles. Geiger and Marsden assumed that mass and charge were uniformly distributed throughout the atom of the gold foil, as one would expect from the plum pudding model. The scientists expected the alpha particles to pass through. However, when the scientists checked for the possibility of wide-angle deflections, they were shocked to find that roughly 1 in 8,000 of the alpha particles had actually been deflected back towards the source. Rutherford concluded that the volume of a nucleus was very small compared with the total volume of an atom. He also discovered that the atom is mostly made of space. In 1911, Rutherford's student Niels Bohr proposed the planetary model, which electrons surrounded the positively charged nucleus as the planets surround the sun. Chadwick's discovery of the neutron. So, Chadwick worked with Rutherford, agreeing that there was another force inside the nucleus, then later worked with the Curies with radioactive elements and discovered decay of elements into smaller, more stable nuclei, revealing the presence of neutrons. Quantum theory. Werner Karl Heisenberg proposed the quantum theory where J.J. Thomson's electrons were contained in orbitals. Quantum theory was usually called the cloud model of the atom, since quantum atoms were often drawn as clouds, and most of this was being based off of probability.